Okay, so before we start doing some of the characterization tests, I just wanted to do a simple physical comparison of the two things. So the crude is over here on the left. This is the crude aspirin, the stuff that we didn't purify. And then this is the purified aspirin over here on your right. Okay, so this will give you a chance so that you can do some observations on the differences between them. Okay, so we're going to characterize our aspirin samples. And so I've got 3 test tubes here, one labeled control, one labeled crude, and one labeled pure. Okay, and so the first set of tests we're going to do is a pH test. Okay, so I'm going to have pH paper here. We're going to use pH paper to judge these. So what I need to do is I need to put 1 milliliter of deionized water into each tube, which is 20 drops. Roughly, and then we're going to add a small sample of obviously the crude aspirin to the crude and the pure to the other one, and we're going to stir them up with these stir rods here that we have, and we're going to see how long it takes for it to dissolve. Okay, so I'm going to try to make sure if we can get this on film. So I think I'm going to change the angle of the camera so you can see how long it takes to dissolve, and then we're going, once we see how long it takes for the aspirin to dissolve, then we're going to test the pH of each of the 3 solutions using the pH paper. Okay, so hopefully now you'll be able to see this and see how long it takes to dissolve. But first I'm going to put 20 drops of water in each test tube. Okay, so there's the same amount of water in each test tube. All right, and I'm going to put a little bit of, obviously in the control I'm not going to put anything, so I'm just going to move these over here. So we got the control by itself. I'm going to put a little bit of my crude aspirin, a very small amount, into the crude, and we're going to stir that up. All right, so we're going to just put a little bit in there, maybe a little more. Okay, and we're going to see how long it takes for that to dissolve. You can see it's not dissolving all that well. There's still some solid here. Okay, hopefully you can see that, and see if I can tighten it up a little bit more. All right. Okay. And there's still a little bit of solid there, so it's still not all dissolved. Okay, but I'm going to let it set because I'm going to want to add a little bit of pure aspirin to that one and get that one started as well. Okay, so I added a little bit of pure to that one. I'm going to use a separate stir rod. Try to get that to dissolve. Okay, so you can see it doesn't dissolve very well in just pure deionized water. And we don't have to get it all to dissolve in order to do what the next test is. Okay, because we didn't measure how much we put in, so we may have even went over what, they may never all completely dissolve, because we don't have very much water in here. Okay, you can see that it's not dissolving very well at all. Okay, and so then the third tube is just a control with no solid in there. Obviously nothing's going to dissolve in that case. Alright, so the next thing we're going to do with these tubes is we're going to test the pH using pH paper. And I'm going to have the camera go down on the white background of the paper here so you can actually see the colors and read off the pH values. Okay, so we've got the camera set up, and there's still some undissolved solids in here, but enough of it has dissolved of what we're going to do to be able to test the pH for both the crude and the pure. Okay, so first though we're going to test the control, and so remember what you're trying to do here is you're going to judge it based on the color. So 0 is up here at the top in the red, and goes 0 to 6 across the top here, and then it's on the bottom colors it goes 7 to 13, okay, for pH. Alright, so that's kind of what we're doing, we're trying to judge. So I'm trying to keep this in the shot as well without getting a glare. Let's see if I can do that. I'll use the box here, prop this up so you can actually see the colors and the numbers. Okay. Okay, so now what I'm going to do, instead of trying to use the stir rod to catch a drop, I'm just going to take a dropper, I'm going to put a drop onto the paper there. Oops, so I try to not get it in the camera. Okay, so read off that pH using the scale here. Alright, next one I'm going to try is the crude. Okay, I got a separate dropper here. Okay, so hopefully you can see that color and read its pH. And now, for the last one, for the pure. Okay, so hopefully you should be able to read the pH for the control, which is just deionized water, the crude aspirin sample, and your pure aspirin sample. Okay, so that's the pH test. The next thing we're going to do is we're going to use these for the phenol test. And so what we're testing here is if there is still an OH group attached to the ring that's in the structure of these compounds. And the way that we do that is we react it with iron trichloride. Okay, so we got a solution of 1% iron trichloride, iron 3 chloride, and we're going to add a drop to each one of these, and so the control will tell us obviously what the color, because the iron trichloride has its own color, so that'll tell us that, and then we're going to see what happens with the crude and the purified sample. Okay, and so if it's pure, right, with aspirin, there should not be an OH attached to the ring anymore, so it should be the same as the control. But the crude, if it has salicylic acid still in it, will turn purple. So we're going to add a drop to the control, and a drop to the crude, and a drop to the pure. Okay. And you should easily be able to see, all right, right, the color, tip it up, you can see that the crude turned a purple color, which means that there is still salicylic acid in the crude, but not in the pure. So that's a simple chemical test that tells us that. Okay, for the last chemical test we're going to try is now we're going to try diluting or dissolving the aspirin sample into a test tube with 10% sodium bicarb. So I have a solution of 10% sodium bicarb, and I'm going to put 20 drops in there. Right? And so before I put in the sample of aspirin, it also says to check the pH of this solution. So I'm going to grab a piece of pH paper. Okay, and so there's the thing. And so instead of trying to get it out of there, I'm just going to take it directly out of the stock bottle, and then I'll show you the color so you can read it. Okay, so. Okay, so you should be able to tell me the pH of the 10% sodium bicarbonate solution. All right, sodium bicarbonate is also baking soda. Okay, so that's the pH. And so we're going to see if we can dissolve up how fast the purified aspirin, because we're only going to do the one, in this solution. Okay. Again, I'm going to put in some purified aspirin, and we're going to see if it dissolves. I don't know if you can see that, but it's all dissolved already. Okay, so it dissolved really well in 10% sodium bicarbonate. Okay, then the last thing we're going to do is we're going to add some concentrated HCl to this solution, aspirin solution in here. We're going to see what happens with that. So let me close up the bicarbonate solution. So here's some concentrated hydrochloric acid, and I'm going to add that in by drops, and you can observe what happens. Okay, so you can see definitely gas formation. Okay, so no longer bubbling. What you might not be able to see, because it's kind of up on the sides a little bit, but there is, I think, some acid, or some of the aspirin coming back out. Let me just do one more drop here. I'm going to see if I can mix it up a little bit. Get some of it off the sides here. Since it fizzed up, that's what's happening there. Okay. All right, well, maybe you can't see it, but you saw the fizzing, and if I got enough, there might just be too much water here for it to come back, but the idea is is if I make it acidic enough with concentrated HCl, that the aspirin will not be soluble, right? It's not nearly as soluble in water. And so there is one little piece floating around in there, but I don't know if you can see it. Okay?